If a big UFO came now, we walk outside and over Westminster, there's a spaceship hovering.
An international team of researchers has made a spectacular discovery, tracking down Kipu, one of the largest known structures in the entire universe. This colossal structure weighs 200 quadrillion solar masses and extends over an incredible length of more than 1.3 million light-years. However, its discovery challenges our previous models, as a theoretical size limit of cosmic giants was thought to be only 1.2 billion light-years. Adding to the complexity, astronomers have also discovered two more giants, the giant arc and the Big Ring, which, according to existing theories, shouldn't exist in their current form. The name Kipu may sound familiar, as it also refers to the unique knot-based recording system used by the ancient Inca civilization to store and transmit information. Appropriately, this newly identified megastructure has been named after this historical system, as it resembles a massive cosmic string composed of numerous long and side threads. What truly sets Kipu apart are its immense dimensions. In addition to its staggering mass, it is 13,000 times larger than the Milky Way. Even the enormous Laniakea supercluster, which contains over 100,000 galaxies, including our own, is not even half the size of Kipu, spanning only 520 million light-years in diameter. The discovery of this XXL cosmic structure came as part of a long-term research project mapping matter distribution in the universe at different wavelengths. Distant cosmic structures exhibit a shift in their wavelength toward the red part of the electromagnetic spectrum, known as redshift. The greater the redshift, the farther away the objects are. While structures with a redshift up to 0.3 had already been extensively recorded, scientists focused the new study on structures with redshifts between 0.3 and 0.6. Utilizing data from the German X-ray satellite Rosat and a specialized algorithm, researchers uncovered not just one but 5 superstructures located between 425 million and 850 million light-years from Earth. These include the Shapley supercluster, Serpens, Corona Borealis, Hercules, Sculptor, Pegasus, and, of course, Kipu. This cosmic quintet alone contains 45% of all known galaxy clusters, 30% of all galaxies, 25% of all matter, and occupies approximately 13% of the observable universe. Such enormous structures have measurable effects on space observations, particularly the cosmic microwave background radiation, CMB, a relic from the early universe that formed about 380,000 years after the Big Bang. Typically, the CMB's measured properties align with theoretical predictions, but structures like Kipu, due to their immense gravity, can distort this radiation through the Sachs-Wolf effect, potentially skewing our understanding of the Big Bang. Additionally, Kipu influences the determination of the Hubble constant, which measures the universe's expansion rate. The superstructure's gravity alters galaxy movements, leading to measurement inaccuracies. It also affects astronomical observations through gravitational lensing, bending the light from distant objects. Despite these challenges, Kipu's existence aligns with the lambda-CDM model, the standard framework for cosmic evolution, suggesting that such superstructures can indeed emerge from known cosmic processes. However, the researchers' work is far from over. The next steps involve investigating Kipu's interactions with galaxy clusters, its influence on galaxy formation and evolution, and its potential role in understanding dark matter. Despite its grandeur, Kipu will not exist forever, as astronomers believe it will eventually dissolve due to cosmic evolution. Interestingly, the existence of Kipu and similar structures contradicts established cosmological models, which suggest that matter should be evenly distributed across the universe. While galaxy clusters and superclusters naturally form, large-scale matter distribution should remain uniform. However, in 2021, researchers identified the giant arc, an enormous arc of galaxies and galaxy clusters stretching 3.3 billion light-years, significantly exceeding the supposed 1.2 billion light-year size limit and defying expectations once again. In January of last year, a research team led by Alexia Lopez from the University of Central Lancashire discovered another vast structure, the Big Ring. Unlike an arc, this cosmic giant is ring-shaped, as revealed by light spectra from distant quasars, which left telltale absorption lines of magnesium ions. Like Kipu, the Big Ring spans 1.3 billion light-years, with an estimated circumference of 4.4 billion light-years, large enough to stretch across the night sky as much as 15 full moons side by side. Though its light is too faint to be visible to telescopes, these findings mean that we now know of 3 enormous structures that directly contradict our current understanding of matter distribution in space. Adding to the mystery, the ring of gamma-ray sources, measuring about 5 billion light-years across, also challenges our models. The discovery that the giant arc and the Big Ring are located in the same region of the sky and are about the same age raises the possibility that they may be part of an even larger cosmic system. Scientists can currently only speculate about the origins of these superstructures. One possible explanation is their connection to baryonic acoustic oscillations, BAO, density waves formed in the early universe through the interaction of radiation pressure and gravity, leaving behind ring-shaped patterns in the matter distribution. However, typical BAO rings only have a radius of 500 million light-years, making it difficult to explain the immense scale of the Big Ring. Moreover, spectral analyses indicate that the Big Ring is actually spiral-shaped rather than circular. Alternative explanations include the cyclic universe model, proposed by physicist Roger Penrose, which suggests that the Big Bang was merely the beginning of a new cosmic cycle rather than the absolute beginning of everything. In this theory, the universe undergoes continuous cycles of destruction and rebirth, with massive rings of Hawking radiation originating from supermassive black holes in previous cycles persisting into the next cosmic age. Another potential explanation involves cosmic strings, hypothetical thread-like defects in space formed shortly after the universe's creation due to the separation of fundamental forces. Their gravitational effects might have influenced large-scale structure formation. However, these are still theoretical frameworks, and the true nature of these superstructures remains one of the greatest astronomical mysteries. Whether we will eventually uncover their origins or continue to encounter even more cosmic anomalies remains to be seen. As research advances, astronomers are sure to make further groundbreaking discoveries that challenge our understanding of the universe.